NASA's Mars rover just found something that shouldn't exist. Something is wrong with the ground on Mars. Not cracked, not chaotic, not the random rubble you'd expect after 4 billion years of dust storms, radiation, and silence. Organized, repeating, perfect. Thousands of identical shapes locked edge to edge, stretching to the horizon like a fossil the size of a valley. And NASA's own scientists are struggling to explain it. At first glance, it looks like tile work, like something built, like the floor of a structure nothing on Mars should have ever been able to construct. It isn't a structure, it's worse than that. It's a memory. A 3.5 billion-year-old scar pressed into solid rock from the last time this entire planet was drenched in water it no longer has. This is Valle Grande. A quiet stretch of terrain inside Gale Crater, halfway up a 3-mile-tall mountain called Mount Sharp. For 14 years, the Curiosity rover has been crawling up this slope, 1 careful meter at a time. It has outlived its own mission timeline by more than a decade. Survived dust storms that swallowed the entire planet. Kept moving long after engineers expected it to go silent forever. In June of 2026, it turned a corner. And what its cameras sent back stopped a room full of scientists cold. Over 2 Martian days, Sol 4930 and Sol 4931, Curiosity fired off 340 individual images, stitching them together into one uninterrupted panorama, a full 360-degree scan of everything surrounding it. A sea of stone honeycomb, not a patch, not a cluster, an entire landscape. Look closer, and each individual cell measures barely 2 to 3 inches across. Smaller than your palm, but there are thousands of them welded together wall to wall, wrapping around boulders, climbing low ridges, vanishing over the horizon in every direction the rover's camera could reach. It even wraps around a 20-foot sand-capped rock formation nicknamed Miraflores, about the height of a 2-story house. The pattern flows around its base the way water curls around a stone in a riverbed. Except there hasn't been flowing water on Mars for over 3 billion years. At least, that's what we thought. Ashwin Vasavada has spent more than 2 decades staring at pictures beamed back from this one robot on another planet. Dried riverbeds, ancient lake beds, sulfur fields, fields of dark, scattered meteorites. He has seen almost everything Mars has to offer. He says this took his breath away. Curiosity has spotted small patches of these polygon shapes before. A few here, a few there. Interesting but minor footnotes buried in a 14-year mission log. Nothing prepared the team for an entire valley wearing the same pattern like a second skin. So what carves solid stone into a honeycomb? On Earth, the answer is almost always the same. Mud, wet sediment that dries under the sun, contracts and cracks along clean geometric lines. Walk across any dried lake bed in Nevada, or a sun-baked flat in the Australian outback, and the exact same shapes stare back up at you. If that's what happened here, it means Valle Grande wasn't always a dead, frozen valley. It means this ground was wet, repeatedly. Soaked, then dried, then soaked again, cycle after cycle, for who knows how many thousands of years, until the cracking pattern locked itself into rock forever. A fossil, not of a creature, of a process. The frozen memory of water that vanished from this planet's surface an eternity before the first fish crawled onto land back on Earth. Mud cracking is only the first suspect. There are 2 others. Temperature cycling is the second. Freezing nights and blistering days repeated for millions of years can fracture rock into these same geometric patterns without a single drop of water involved. And compaction is the third. Layers of sediment buried and crushed under their own weight can force trapped water out through cracks that form these exact honeycomb walls. 3 suspects, 1 crime scene, and right now, nobody can say for certain which one is guilty. That alone would already be the biggest story of Curiosity's 14-year mission. But here's where it stops being simple. Just 2 months before this discovery, in April of 2026, Curiosity's onboard chemistry lab cracked open a different rock sample from this same ancient lakebed system. Inside, buried in clay that hadn't seen sunlight in 3.5 billion years, it found 21 separate carbon-based molecules. 7 of them had never once been detected on Mars. 1 of them stopped researchers cold, a nitrogen-bearing ring structure, the exact class of molecule that on Earth sits 1 chemical step away from building RNA and DNA, the literal genetic alphabet of life, sealed inside Martian rock since before Earth's oceans had finished forming. Scientists were careful. They said this doesn't prove life ever existed here. It proves the ingredients were sitting on the shelf. Whether anything ever walked into that ancient kitchen and started cooking is a different question entirely, one they cannot yet answer. Now put both discoveries side by side, a valley that was soaked and dried for long enough to burn a permanent geometric scar into solid stone. And underneath it, sealed in that same ancient clay, the precise chemical building blocks life would need to get started. 2 separate teams, 2 separate instruments, 2 separate discoveries, published only weeks apart. Neither team was looking for the other's answer. And yet here they are, sitting on top of each other in the exact same stretch of Martian rock. Coincidence? Maybe. Compression alone can create honeycomb shapes just as easily, squeezing ancient water out of buried sediment the same way you'd wring out a sponge. No biology required anywhere in that process. Just physics, patience, and unimaginable amounts of time. But ask yourself this. What does a microbial mat actually look like after 3.5 billion years of pressure, radiation, and slow mineral fossilization? What remains once every trace of soft tissue is gone and only the outline of where something used to be is left behind, pressed into stone? Nobody actually knows because we have never found one to compare it to. Not on this planet, not on any other. Every fossil we've ever studied came from a world we already knew was alive. Mars gives us no such guarantee. Whatever pattern life might leave behind here, we would be seeing it for the very first time in human history, with no textbook, no comparison, and no second opinion to check it against. Right now, on the far side of the solar system, a rover the size of a small car is parked in the middle of that valley, running chemical tests on rock nobody has ever touched. And every scientist watching the data stream in is quietly asking the same unanswered question we are. Was this valley just wet? Or was it alive? 2 questions, 1 valley, and a rover that isn't leaving until it finds out which. Mars was not always the frozen red graveyard we've spent 60 years photographing. It had lakes, it had seasons, wet years and dry years, cycling for who knows how long, carving honeycomb patterns into stone that will outlast every living thing that may or may not have once crawled across it. Somewhere under that dust, the real answer is already sitting there. Waiting, patient, the way only a planet with nowhere left to go can afford to be. If you think Valle Grande is proof that something once lived on Mars, say so in the comments below. If you think it's just physics doing what physics always does, say that too. Either way, I want to hear it. And if stories like this one keep you up wondering what else is buried out there, subscribe to Observable Horizon, because the universe keeps leaving clues exactly like this, and we are not going anywhere until every single one of them has been dug up.